Hi all, in this video we will talk about singleton design pattern. So what is mean by a singleton design pattern? So singleton design pattern helps you create only a single instance for a class. Okay. Now here if you see you have a singleton, a class named singleton, and you want to create only a single instance, only one object for this class. Okay, then you might wonder why you need only a single object, because classes are designed to create multiple objects, right? But there are some scenarios where you need only a single object. Like if you are creating a logger object, then you need only a single logger object. Or if you are establishing a database connection, then you might need, or some in few cases you might need only a single object. And let's say you are registering your database like driver details and all, you need to register only once, not repeatedly, right? So in those cases you need a singleton object. And even if by mistake a developer, if he's trying to create another object, another instance of this class, then you should not allow him create another instance. Okay, so and as I was explaining you in the previous video, let's say if you want to create only a single instance of an university class, then in those cases also you need to create only a single instance. So in all these cases you need only a single object for a class. And how to achieve that? Okay, now this is the class named singleton. Now my aim is I want to create only a single object of this class. Now everyone says that by default you have this constructor, right? In like this is, even though if I don't write it, you will have a default constructor here. Now in the main class, if I do like a singleton, yeah, here in this main class, now I can create an object singleton equal to new singleton. So this is the way of creating object in Java: new and then the class name. Now another person also, now I have created this object, right? Another person can also create another object like new singleton. Then in this case another instance gets created. Okay, then how to avoid that? So since whatever this new singleton, it's a constructor, right? Because by default, this, even though if I don't specify it here, by default this constructor is there, it's already added by the Java. So now since you have made this constructor as a public, everyone is allowed to use that constructor. Okay, now what I think is, okay, since everyone is using this constructor, it is leading to the creation of multiple instances of this class, which I don't want. Is what I can do is I can make this constructor as a private. So if I make this constructor as private, even I can't create it. So even a single instance here, it throws error for both, because private, whatever the private ones it's there, it's not accessible from another class, right? So you can't create even a single instance here. Then what is the another approach you can follow? But I can't make this as a public. If I make this as a public, what happens is it leads to multiple instances, so I can't make it. So I put this as a private, but I'll explore other methods. How can I create, and like how can I instantiate this class with only one object? So now what I get is I can do it during the class loading itself. Okay, whenever Java initiates, it can load it. So further, you already know, right? In Java, static variables and static methods are executed during the loading time itself. So what I can do here is I can do singleton and then new singleton, because this private is whatever the private constructor we have, it is accessible from inside the class, not from outside the class. Okay, now here you, since you can't use in any other class, what I'll do is I'll use this static variable. Okay, static variable, and then what I can do is I can create this. Okay, now what happens whenever the classes are loaded, automatically this singleton object is created, and from here what I can do is I can use this singleton object. So this is my like this is my variable. Okay, like let's say singleton object obj, Now if you like, if you access this, because since this is a static variable and this is a public one, what happens is you can get a single object. And since you made this constructor as a private, no one can initiate this class, instantiate this class. Okay, now we achieved. Okay, I have created a single object and it happens by loading itself. And since I made the private constructor as the private, no one can no one can create another object. And I can access the object which is already created by using class name dot variable, because this is the static variable, right? And the static variable can be accessed by using the class name instead of the object. Now I achieved it, but there is a drawback here. So what is the drawback? Here, in few cases, you might not need the singleton object at all. It depends on the situation or the use case. For few use cases, you want this object, and for few use cases, you don't need it at all. Maybe you have like if you're working on an application, in few cases you don't need this object at all. So even though you don't need this object, but during the loading time itself this was created and this is never being used by anyone. Now here, since I need this, I access using the variable. In few cases I don't need this, then whatever the object that is created, it is like there, like you are just wasting the memory and no one is using it. So this is called this eager initialization. Okay, so automatically it got created, but if you don't use it, then it's become a problem. So that's why what we'll do is we will not instantiate while loading itself. Okay, now what I will do is, anyway, since we made it private, I can't access from other class, right? I'll create another method. Okay, I'll create another method named get instance of, and in this I'll create object. Okay, now return new singleton. What happened here is, yeah, I'll add this return type. Now what happens here is return new singleton, and you don't need this as well. No, what return new singleton object if singleton, if null equal to singleton, then what you can do is you can create new singleton, and then what you can do is you can do singleton. Okay, now I add this method, and if I need an object of singleton, what I can do here is, say, I can just call that method singleton dot. Since it's a static method, I can directly invoke that method, right? Singleton dot get instance of. So this singleton dot get instance of will give you the object, singleton object, and you can use the methods mentioned here. So one advantage over the before approach is, before, even though you don't need it, by default your object is getting created. But here, whenever a user requests for an object, then only it will check whether the object is already created or not. If the object is already created, then it will return that object. If the object is not created, then it will not, if the object is already created, it will return that. If the object is not created, it will create that object and then it will return that. So that's why we have null check here. Let us suppose for the first time developer is asking for the new singleton object. Here he has asked, right? For the first time he has asked it. So what it does is it will go and see if the singleton variable is null or not. Since we have not created any instance, by default it would be null. So I created new singleton of. Now you are returning the created object. Okay, now you have created one instance of this singleton. Now another developer, let's say another developer asks for the he also invokes the same method, singleton dot get instance of. Now what happens here is this value won't be null now, because we have already assigned it. So it won't be null. Then it assumes that it was already created and then it will just return this value. Okay, now with this approach, what we have done is we have created a single object, and and you don't have any errors here. Okay, but if you run this code in the production, there are cases where you will end up in creating at least another instance of the object. Okay, it's not 100% sure, but it can be possible that you might end up in in more than one instance of the singleton. Like you might wonder why it happens, because I have put this null check here. If it is null, then only I will create it. If it is not null, then I will not do it. Okay, then why we will get another instance, an extra instance of the singleton? Because you already know that, right? There are threads in the Java. So if your application is running in a multi-thread environment, then definitely you will end up in creating an extra instance. So how that happens is, let's say thread 1, there are two threads, okay, thread 1 and thread 2. Now thread 1, like this user here, you are using a single thread for both, right? So first this thread will execute this, and then it will execute this in a serial manner. So if it is getting executed in a serial manner, then definitely you don't have issue. You will end up in creation of only a single object. But if you use multiple threads, like for this instance if you use thread 1, and for this line if you use thread 2, and both invokes this method at the same time. Okay, now what happens is thread 1 invokes this method and thread 2 invokes this method, and both thread 1 and thread 2 checks this value at the same time. Okay, when it checks this value at the same time, what happens is both sees that okay, this value is null. Okay, this value is null, and they will enter inside it, and then they will create two objects. Okay, now first thread, it will create new singleton of object and it will assign to singleton, and the second thread also it will create a new singleton object and it will assign to singleton. Though you assign only a single object to this, but in memory you have two objects, right? So that is not an expected scenario. So to handle this multi-threading part, what you can do is you can use this synchronized one. So synchronized, you already know, right? If multiple threads are there, only a single thread can enter this method, and another thread can enter this method once the first thread exits from this method. So at any point of time, you can see only single thread executing this. So in that case, you will have only a single object. Okay, but the drawback here is synchronized. You already know the thread synchronized comes at the cost of the performance. Now if there are multiple users which needs this singleton, now I need this singleton instance. Okay, another developer also needs this singleton instance, and another developer also needs this singleton. He wants to invoke few methods of this singleton class. Then first one, it will get the instance, and the second one has to wait till the first one gets the instance object. Okay, and the third developer has to wait till the second developer gets it. Okay, so it will reduce the it will reduce the performance. Okay, so for that, what we can do is, instead of putting synchronized here, what we can do is we can add additional things. Now first thing is, if null is like if the singleton object is null, what you can do is you can add synchronized of singleton dot class, and then you can add another check. Now what you can do is, if null equal to singleton, now this is like double locking method. If you put synchronized on this method, what happens is it will reduce the performance, because if you put this every thread, like you have multiple developers who is waiting for this instance, or multiple use cases which is waiting for this instance, right? Then everything gets executed in a serial fashion. So if there are 10 resources that are waiting for this particular instance, and the tenth person gets at the last, and he has to wait till he gets the instance. So instead of putting synchronized on this, I'll go for the double locking mechanism. So what is double locking mechanism is, so initially what is our like if you don't put the synchronized, what is our problem? Both thread 1 and thread 2 can execute at the same time, right? Now let us assume both thread 1 and thread 2 enters this method. Okay, and both sees the value as null. Okay, both sees the value as null, and then both thread 1 and thread 2 enters internally. Now what you are doing is, now we are locking this class. So when you lock this class, only one thread can enter inside. Okay, now inside this null you have both threads, but inside this synchronized block you have only one thread. So let us assume first thread goes to this 13th line. Okay, now it will see null, if like singleton is null, and then it will create the object in the memory. Now it comes out of the block, and then thread 2 enters the block. So it will log the singleton object, and then it will again check, okay, if the null is singleton. Now your singleton object is not null, because thread 1 has already like created and assigned that created object to the singleton. So what thread 2 does is, it won't create another object here, and it comes out of this synchronized block. So with the help of this double locking mechanism, you can create only a single instance of this class, but and you avoid this multi-threading issues as well. Like, and the performance of this is much better than putting this complete method as a synchronized, because you will synchronize only if the singleton object is null. But in the before case, you are synchronizing even if it is null or not. You did not put that check. So here initially you have two checks, double locking. Here initially you saw if it is null, and then you lock the object, and then you again check if it is null or not. So this is called a double locking mechanism. So to create a single instance, what we have done, the first method is like create the object during the loading phase itself. So if you do this, the problem is, if you don't use this object, then it is there is no need of creating this object. But if your use case is for sure, if you may like for sure, you are sure that you use this object, okay, you are 100% sure that you use this object, then you can go with this approach as well. There is no issues. So it depends on your use case and how your application works. But in few applications, it's not guaranteed that by like they will use this created object in all cases or not. So that's why we did not use this approach. But if you are sure that your application needs this object, then you can go with this approach as well. You don't need to do this all these things. But if you're not sure that might or might not be the developer's needs in this instance, then you can go with this public part. Okay, public static singleton double locking mechanism. And in few cases, what people does is, they can simply go with the synchronized also. But if they like, if there are less invocations to this method, get instance method, right, then they know they don't need to put all this double locking mechanism. Okay, but if there are more invocations to this get instance method, then you should not use this one. So these are the approaches that can be used to create a single instance of an object, but it depends on your use case or the behavior of application. So if your application is using this object 100%, if you are sure, then you can go with the first approach. If you don't have any performance issues with the synchronized keyword on the method, you can go with the second approach. And if and you can go with the double locking mechanism if the other two approaches don't work. Okay, yeah, thank you.